Equilibrium with forces and moments. Example 1. So we have a uniform beam of weight 30 newtons, so the 30 newtons acts at the center. The beam is supported at each end, so we have normal reaction forces of 15 newtons each. So if we look at the vertical forces, they should be in balance because of equilibrium. So 15 plus 15 is 30 upwards and 30 downwards. They are in balance. We add two particles of weight 10 newtons each. They are placed an equal distance from the center. The total weight now for the beam and the particles combined is 50 newtons. That weight has to be supported at each end. So these values are now wrong. They add up to 30 and not 50. These are the correct values, and this is the correct diagram. So remember, the weight of all of the objects, that's the two particles and the beam, the total combined weight is 50 newtons, and all of that weight is supported here and here. So these two must add up to 50 newtons. Now this diagram is incorrect. The total weight again is 50 newtons, and all of that weight combined is supported here and here, but these only add up to 30. They don't add up to 50, so the diagram's wrong. Even though if you look at vertical forces, the upwards forces add up to 50, the downwards forces add up to 50. Example 2, we have a uniform beam of length 5 meters. Its mass is 40 kilograms, so its weight is 40 G at the center. It's resting on two supports placed 1 meter from each end. A man, mass of 80 kilograms and weight 80 G is placed on the beam, and we are given that the normal reaction at D is twice the normal reaction at C, and we have to calculate the length AE. Resolving forces vertically, taking the upwards direction as positive. So R plus 2R minus 40G minus 80G will be equal to 0 because of equilibrium. So we can solve to work out R. R is equal to 40G, where G is 9.8. Now taking moments about point A, and the clockwise direction is taken as positive. So we have 40G times 2.5, the perpendicular distance, and this force is pointing downwards, and about point A that would produce a clockwise rotation, so it's positive. And then we have 80G, and again that's pointing downwards, and the distance A to E is unknown, so we have a positive moment. Both R and 2R are pointing upwards, and the upwards forces create an anti-clockwise rotation, so they are both negative. So R times 1 there, and 2R times this distance, which is 4 meters. Yeah, it's the 5 meters, the length of the rod, minus 1 meter. And all of that equals 0, the resultant moment, because of equilibrium. Now when simplifying, we know the value of R, it was 40G. Simplifying, we get AE is equal to 3.25 meters. For further practice, try these questions.